in AP Calculus.
Go.
Today's date is Monday, February 24th, 2/24, 2020. We are on Unit 10. There are only 3 lessons. It will go fast. Oh my gosh, I keep forgetting to change it. Yeah, it is. Our objective is to do what, Arrow?
Oh, on the board.
Use the FTC to find f of c when c and f prime of x. When given c and f prime of x, both algebraically and geographically.
Graphically. Thank you, Gio. Now I won't have to give anyone extra credit points. Yeah, what does FTC stand for again? Quite raised hand. Who knows FTC? Fundamental something something? Those are all not raised hands, but you guys got it. All right, so it's not too big of an issue in this class. There's like hardly anyone in here. All right. That's interesting. My notes are different from last year's specific values. I guess I changed it. So forms of derivatives. So let's say I have capital W. If I want to take the derivative of W, I can call that W prime, but more specifically, more formally, this is D capital W over D, I don't know, what am I integrating with respect to? Usually time happens, so I'm going to say dt. And if I take the derivative again, I am left with what? Who's got this? What's the second derivative of W in terms of this Leibniz notation? There's a capital W, there's a T, there's squares that go somewhere and somewhere.
d squared w. What? d squared t?
dt squared. Yeah. So the square goes on the outside and then the inside then outside. That's just how to talk about the second derivative. What if I'm talking about position? So if I have like x of t, let's say that's position. I could have done y of t, I don't know. If I take the derivative of position, I'm getting what? Derivative of position is?
dx.
It's
Velocity, yeah. Derivative of position is velocity, v of t. And derivative of velocity is? Acceleration, exactly. Nice. Okay, so we're waking up from the break. This is a good lesson to do after the break. So if in general, anything, I'm just going to say some value. And if I take the derivative, I'm going to talk about the rate of that value. So let's say rate of the value. And if I take the derivative of the derivative, it's the rate of the value. So I'm just going to say the rate of the rate. Rate of the rate. How fast is the rate changing? So we all have a good review on first and second derivatives. So let's talk about functions now. Those are specific functions, general functions. If I have some f of x, the derivative, we'll use prime notation now. So this is going to be, what, shout it out? F prime of x. And the second derivative is? Del prime of x. Nice, yeah. Okay, what about, let's try the other notation. Let's do the fraction notation. So if I do y, this is going to be dy. Let's do it with respect to x. So dy dx. And again, the second derivative, d squared y over dx squared. Exactly. And you can kind of just copy paste here. It's value, rate of the value. It's the same thing with a general function. The rate that value is increasing, and then the rate of the value. All right, so the main thing that you're going to be using today for the homework is the fundamental theorem of calculus, where we're talking about the difference between a specific versus a general. So let me give you this. So our start plus change is equal to, or what? Start plus change equals end. Yeah, so I'm going to actually flip it on its head, and I'm going to say end is equal to start plus change. Because I'm always asking, what is the end? So that's the question mark. So if I say, what is W of 20, capital W of 20, you'll say, okay, well, you have to start at whatever your initial condition is. We don't know that, so I'm going to say our initial condition is capital W of 0. That's our initial condition. So if I say x of 0, or sorry, x of, I don't know, some number, 5. I just randomly chose 5. Then our start condition is x of 0. This is just my notation way of saying, what is your start condition? Usually they'll say, hey, you started at 5 or you started at $2,000. That's what you plug in right here. That's just the notation for it. This is kind of the key part though. So the change, when I'm talking about something that is specific, that's going to be an integral between some bounds between our start and end. So let's say between 0 and 20 of what? Be very careful about how you do this.
W dt.
dw dt, yeah. D capital W over dt, yeah. dw dt dt, precisely. The main thing to take away here is whenever I'm trying to find capital W, I need to take the derivative, or sorry, the integral of W prime. This all sounds familiar. We've done this before. Things are about to get tricky, so let's make sure we really have these down. So this is going to be start plus, what's our change? Integral from where to where?
0 to 5.
0 to 5. Of what?
Dx.
Let's say x is position. So it's going to be,
X.
what is the derivative of
Velocity.
position? Exactly, velocity. Vt dt, velocity. Let's say, what if we wanted velocity? Velocity of, oh no, shout out a number. 2, sure. Velocity of 2. Let's say our starting condition, we start at time equals 0 typically, so sorry, v of 0. Plus the integral from where to where, Stego? Of what? Yep, acceleration, a of t, dt. Precisely. Okay, so this is where I'm going to start getting a little bit more general. I'm going to make it super, super general, and then this is going to be the final result of what we're trying to get to. So very, very generally, if I want to get to any function, let's see, f for function, any function for some value b, I have to first start at f of, generally speaking, a. I go from a to b. My integration is going to go between where and where? What are our time values? A and b. Of what? F prime of t, yeah, t dt. So that's super general. This is what we're going to be seeing today. They're called accumulation integrals. And I'll write this as a note. This is called accumulation. I ran out of room. Accumulation intervals. And they look like this. Let's change to a different letter. Instead of F, let's choose G. Okay, G of B. I'm going to say I know my start, but I don't know how far along I'm going to go. So I'm going to say I know my start. Let's say it's G of 0. Therefore, our integral is going to be between where and where? 0 and B of G prime of t dt. On free response, I don't think they even mark you down. I don't think so, but I'm not 100% sure about that. You have just created an accumulation integral, and that means I know my start, you'll say 10 or something, whatever that start is, and then you'll have this weird bounds where you know your start time, but you don't know your end time, so that end time has to be a variable. Your answer now will have a variable for your end time. That's the only twist that I'm adding in here now. Okay, that's basically all the new information I'm telling you is that final line there. And there's one additional rule that you have to remember. If I need to have the integral between a and b, but instead it's b to a, how do I flip those? Do you remember the rule? Yeah, negative. Negative a to b of that same f of x dx. How am I doing on time, Claire?
4 minutes so close. I was counting as soon as it hit 5. Yeah.
But yeah, that's all you really need to do the homework today. So let's go ahead and work on the homework now.